Alrighty, we're doing 5.3, solving equations. So what we're going to do, we're trying to get x by itself, but we have trigonometry. So we are going to add 1 to both sides, cancel. It's just the same as solving an equation. Divide by 2, and then you need your unit circle for this. So where does sine equal 1/2? That is going to be where x equals pi over 6 and 5 pi over 6. All right, the one catch to this is that sine has a period of 2 pi. So every time we do this with sine, we're going to have to add 2 pi in. That just means we can go around the unit circle as many times as we want, and as long as we land on pi over 6, that we're going to have the sine equaling 1/2. All right, doing the same thing with cosine for the next one. Now, cosine equals 1/2 when x is pi over 3, and then I went ahead and put plus the 2 pi in, and also 5 pi over 3 plus 2 pi in. So you just need to know the period. All right, number 2, this one says in the interval 0 to 2 pi, so this means we are not going to put that plus 2 pi in because we are just going around that unit circle one time. So we are going to solve this like normal. I'm getting everything on one side first. All right, so now you're looking where does sine equal negative root 2 over 2. That is where x equals 5 pi over 4 and 7 pi over 4. All right, again, we didn't put the plus 2 pi in because it said just in the interval of 1 unit circle. All right, we're doing the same things down here on number 3. Just trying to get x by itself. This one's a little different because it's tangent squared x, and so first, the next step that we do is square rooting both sides so that we just have one tangent x, but whenever we do that, we need to put a plus or minus because square roots could be positive or negative, and I end up putting that at the end of this one whenever I'm solving it. All right, we need to rationalize the denominator. All right, and at some point I remember to put that plus or minus in there, I think. There we go. All right, so where does tangent equal plus or minus root 3 over 3? That would be at pi over 6 plus pi in, so tangent has a period of pi instead of 2 pi. And then 5 pi over 6 plus pi in. Moving on to B. It's about the same thing. All right, bringing back some algebra skills, splitting it up into 2 square roots. So now I have sine x equals plus or minus root 3 over 2. All right, because of this plus or minus, you end up with pi over 3 plus pi in and 2 pi over 3 plus pi in. But if you had gone ahead and solved for sine x equals positive root 3 over 2 and sine x equals negative root 3 over 2, you would have ended up with 4 things plus 2 pi in, if that makes sense. So you would end up with 2 different x values for the root 3 over 2 and 2 different x values for the negative root 3 over 2, but they end up only being pi apart. Don't worry too much about this part. But on number C, or letter C, you subtract 2 cotangent x from both sides, getting everything on one side and getting it set equal to 0 so that you can factor. All right, and now we put both of those factors equal to 0 to solve, just like we would factor a typical equation. So cotangent x equals 0 at pi over 2. And then cosine x equals plus or minus root 2, never. So that one's no solution. So we're just looking back at that x equals pi over 2 and adding that plus pi in because the period for cotangent is pi. Letter D, we're doing the same thing, getting everything on one side, and then we will factor. All right, while you're doing this, just remember the period thing, the plus pi in or plus 2 pi in. Don't worry too much about that. We can get into that later. As long as you're getting the main thing, like the pi over 2 for letter C, then you're doing a great job. So for this one, sine x equals 0 at pi, and sine x equals 0 at 2 pi. So those are only pi apart. That is why this one is going to end up being plus pi in a minute. Sine x never equals 2 and never gets bigger than 1, so no solution for that one. And then you see I write x equals pi times n. So at pi, 2 pi, 3 pi, 4 pi, all of those places, sine is going to equal 0. All right, we've done some like this before where you would factor it like a typical quadratic, and you're really, really good at these. So just switch the sine squared x to an x squared. Go ahead and factor that out. You taught me this little trick. And once you get that down to the final factors, you can switch out the x for the sine x like we did in the past. We just didn't solve them yet. So we're going to solve them this time. All right, so switching this to sine x minus 1 and 2 sine x plus 1 equals 0. Again, we set both of these equal to 0, so sine x minus 1 equals 0, and 2 sine x plus 1 equals 0 to find our solutions. And again, this one says on an interval 0 to 2 pi, so you don't need to worry about the ends. So sine equals 1 at pi over 2, and then solving the other one, sine equals negative 1/2 when x is 7 pi over 6 and 11 pi over 6. This one is the exact same as letter A, just with cosine, so I knew it factored exactly the same, just switching out the sine x for the cosine x. And then solving for cosine this time instead of sine. So cosine x equals 1 at 0, and cosine x equals negative 1/2 at 2 pi over 3 and at 4 pi over 3. Letter C is a little different because I have a secant squared and then a tangent squared, so I want to get those as the same base, like I want it to both be secant or I want them to both be tangent. I decided to change tangent into secant, but it would have worked either way using one of those Pythagorean identities. So go ahead and plug in that identity, distribute that negative 2, and combine your like terms before you go any further. I messed up. So 3 secant squared x minus 2 secant squared x is just going to give me 1 secant squared x. Minus 2 equals 0. So this one we don't have to factor the same way, which is nice. We are trying to find where does secant x equal plus or minus root 2. And this is when x equals pi over 4 and 3 pi over 4. So check your unit circle, make sure you're understanding how I'm getting those answers. All right, this one I don't have a choice of which one I switch because I only have sine squared and then just a regular cosine. And sine squared has an identity where I can change it to cosine squared. That's what I'm doing. And then I'm going to distribute that too. Combine like terms. And factor. All right, right there, I just put that little squiggle because I was switching out the cosine squared x and the cosine x to just x's so I could figure out how it factored before I switched back to cosines. So that squiggle doesn't mean too much. All right, I went on to the next page a little bit just because I ran out of room. Sorry about that. So I made it cosine x minus 1 and negative 2 cosine x plus 1 equals 0. So those are my two factors that I set equal to 0 and solve. So cosine equals 1 when x is 0. And cosine x equals 1/2 when x is pi over 3 and 5 pi over 3. All right, that's part 1. I will, I don't know what happened. All right, that's it.